Welcome to the second webinar of 2020. I'm Aaron Hill, Vice President at Sawtooth Software. Today's webinar is Applied MaxDiff, and our presenter is Keith Chrzan, Senior Vice President of Analytics here at Sawtooth Software. Keith has over 30 years of marketing science experience in a variety of client, supplier, and consulting roles. Prior to joining Sawtooth Software, Keith was the Senior Vice President, Chief Research Officer for Merits Research, where he led the Marketing Sciences Division, developed new design and analysis products, and conducted tests of new developments affecting the research industry, like mobile data collection, neuroscience, and behavioral economics. Keith is a joy to work with, and we're happy to have him on this webinar today. As we go through the webinar, please use the chat and the Q&A functions to ask questions, and we will answer those questions at the end of Keith's remarks. So Keith, take it away. The screen is yours.
All right, thank you, Aaron. You have to stop sharing, it looks like, before I can go. Okay. All right. Looks.
You good, Keith?
Yes, I am. Hopefully you can see my screen now.
Excellent.
Wonderful. Okay, so this is the Applied MaxDiff webinar. My colleague Bryan Orme and I wrote a book late last year, and this is sort of a 1 hour highlights reel version of that. So I got to pick some of the things that I thought were most interesting, or that I thought would be interesting to the widest audience, and that's what we'll be sharing today. We're going to just briefly introduce what MaxDiff is, in case there's some folks who aren't familiar with it. Talk a little bit about designing a MaxDiff experiment and how we estimate the utilities, how we can rescale the utilities in any kind of research, because sample is typically expensive or very expensive. Sample size is an issue, and so I want to talk a little bit about that. And then we want to talk about some special things that we can do with MaxDiff, something called anchoring. Talk about the problem of large numbers of items, because when a research method gets popular, people try to push it to the limits, and they've done that with MaxDiff. We'll talk about some other, throughout that, we'll have talked about some of the analyses we can do with MaxDiff, but we'll talk about some further things we can do right before the end there, and then we'll talk about something called best worst case 2 scaling, or the profile case of MaxDiff. And then we'll turn it over to questions and such. Okay, so as marketing researchers, we know that we're often called upon to evaluate lists of items. Those items could be brands or attributes. They could be message executions or just message elements. Maybe they're maybe there's 25 things we could say about our products, and we want to find out what the 3 or 4 most impactful things are so that we could turn them into an execution. Maybe we're a company that develops new products, and we've got 40 new product ideas and we want to prioritize them. Or maybe there's a lot of things we could do to fix our existing product, and we want to figure out which ones float to the top there. In short, this need to compare items is extremely common. It's something, it's a problem that almost all of us face. And we know that rating scales perform poorly. Different people use rating scales in different ways. Although they look like they have objective meaning anchors, they typically don't. What's the difference between agreeing and strongly agreeing? Well, that might be different for me than it is for you. We also know that rating scales lack discrimination. There's nothing from preventing a respondent from saying everything is important, and so often they will. And then we're left with, hey, we researched 300 people and we don't have an answer to our question because there's no significant differences here. Finally, we know that at least with respect to importance measurement, rating scales lack predictive validity. There were a series of articles in the Journal of Marketing Research in 1973 that definitively improved that. And now here we are almost 50 years later, and people are still using rating scales to measure importance, which is kind of silly. Anyway, so that's where MaxDiff comes in. It was proposed by Finn and Louviere in 1992. It's also called best worst scaling. If you want to do any reading about MaxDiff and you want to look at the academic literature, you're going to want to search for the term best worst scaling, because that's usually how you'll see it called in academia. It's essentially a multiple choice extension of of the classic method of paired comparisons. Remember from the 1920s, Thurstone developed paired comparisons. Which one of these two things do you like more, A or B, A or C, C or D? And from asking enough of those, you can figure out how much people like each thing. MaxDiff is sort of a multiple choice extension of that, because typically instead of just showing two things, we're going to show 4 or 5 or 6 and ask people to pick the one thing they like the best and the one thing they like the worst. Interestingly, we know from a lot of research that's been done, if you give people a rank ordering, if you ask people to rank order things, they rank order the things at the top of the list really reliably, and the things at the bottom of the list they do really well too. They answer those with great reliability, and the stuff in the middle has a very much larger component of error. People are really confused about what's in the middle of a rank order. So when we give people a list of things and ask them to tell us what the best thing is and what the worst thing is, we're really playing to a strength that people have. We're asking people to do in a survey something they do really well. And that's just wise. It's wise to ask people to do natural tasks. We'll get better data. So here's just an example of what a MaxDiff question might look like. If which one of these things would you most like to do on your next vacation, and which one would you least like to do? And I look at these things and I think, oh, that sandy beach looks pretty nice. So maybe I'm going to pick that as most. And I'm not much for riding horses, or maybe horses aren't much for carrying me, one or the other, but I would probably pick that the least. If we had 20 of these vacation activities to test, we might, for example, ask 12 questions like this. And each of those questions would have a different subset of 5 items. So I mentioned that MaxDiff it's respondent-friendly, right? It's an easy thing to do because it capitalizes on a way that our brains work naturally. In fact, it's so easy to do, in fact, that in the academic literature, you'll see that it's fairly common when used by healthcare researchers. They use it a lot when they're studying impaired populations, maybe elderly people or people who are very sick, people who might not do a good job of answering complicated survey questions seem to do quite well with MaxDiff. It's also information dense. If you think back to that question, just by clicking on 2 items, if someone had picked sandy beach as their favorite thing and zip lining as their least favorite thing, then we would have learned all these pieces of information about them. We would have learned that they prefer a sandy beach to all 4 of the others in the question, and that they prefer each of the remaining 3 to zip lining. So in other words, we would have of the 7 possible, of the 10 possible pairs of items, we learned about 7 of them from just 2 mouse clicks. So it's a very efficient way to collect preference information. 2 little pieces of effort by the respondent, 7 pieces of information for the researcher. What a deal. I see MaxDiff used for a lot of things, measuring the appeal of new products or new product concepts. If a restaurant is considering which desserts to offer, I've seen MaxDiff studies of which varieties should we offer on our menu that people, that we're going to give people what they want, what kind of flavors of bubblegum, colors of packaging. I've just been talking to a client today who wants to use MaxDiff to measure the importance of a list of attributes that they have, and then to measure the performance of each of several brands on those attributes. And they want to do all of that with MaxDiff. And then I do a lot of MaxDiff studies that have to do with evaluating message elements from a larger list, or perhaps messaging executions once those lists have been put together, into prose. Just for example, if we were doing that dessert study I talked about a minute ago, we might ask a dozen questions of each respondent, something like this. Think you're going to a casual dining restaurant and, thinking of just these 4 desserts, which one would you like the best and which one would you like the least? Or for importance scaling, think about that casual dining restaurant and which of these 4 elements is the most important to you and which is the least important to you. And the respondents go through, and you can see that these are relatively easy questions for people to answer. Turns out that if you're used to working with conjoint analysis, you're used to conjoint analysis being kind of fussy. It's difficult to make the designs. It's complicated to run the analysis. There's all sorts of things you gotta watch out for. MaxDiff is a different kind of animal. In fact, sometimes we can make simple designs with a standard balanced incomplete block design that we could pull from a design catalog. We could go to the Cochrane and Cox book, and if we had 13 items and we wanted to ask them 5 at a time, there's a standard design in there. We don't even need to do anything fancy. And in fact, when you see the kind of MaxDiff experiments that academics put together for their publications, they are often using designs straight out of catalogs. More often, however, because marketing managers don't always they don't always require that their problems fit neatly into a catalog design. We're often in a position of having to work with near perfect designs. And so we can go to a computer and use a search algorithm to find a good design that's nearly a perfect balanced incomplete block design for any number of items shown any number at a time. And the way those computer algorithms work is they balance how often each item appears. They want each item to appear equally often. They try to balance how often each pair of items appear together, because again, that perfect balance is what's going to allow us to analytically extract how valuable each item is relative to each other. And then because we know that survey researchers are sometimes a little bit lazy, we want to balance how often each item appears in each position in the question. How often is it in the first position, the last position, the second position, the third position? We don't want there to be any positional bias among our items. So we'll use a computer, we'll go ahead and specify some inputs, and then the designer will make a nice design for us using those criteria. And some of the inputs that we have to come up with are, how many items, we need to know how many items in total we're going to be studying. That's an input to the computer algorithm. And in commercial applications, unlike in academia, where I think the largest number of items I've seen in an academic paper has been about 17. But in commercial applications, we're often pressed to do much more than that, 10 or 20, 30, 40, 50, 100 items sometimes. So that's an input. We want to figure out how many items to include per question. So I showed you examples that had 4 or 5 items. And the reason is that some theoretical and some empirical testing that we've done really suggests that 4 to 5 items per question is probably the best way to go. And then we need to ask how many questions to ask each respondent, because these questions, they do, after you've answered 8 or 10 of them, they do get to feel a little bit repetitive for the respondent, and we don't want to fatigue the respondent because we suspect we'll get less quality data. So typically we want to ask enough questions so that each respondent sees each item at least 3 or 4 times. So we just take we take the number of questions times 3 or 4, whatever we're looking for, divide by the total number of items, and we'd like that number to be, so we'd like to get that number of views. MaxDiff questions can feel repetitive, however, so as the number of items grows, sometimes we'll opt to back off that a little bit and say, maybe instead of showing each item 3 or 4 times, maybe we could get by with 2 or 3 times. Maybe in an extreme case, we could get by with just showing each item once. We'll talk about that a little bit later. Once we've made these decisions and hit the button, the computer search algorithm will look for we'll create a design for you with that number of questions for that number of items and that number of items per question. And also you can specify a number of blocks that you want to have in your design, or versions, so that not each respondent is going to see maybe the same set of 12 questions. Maybe each respondent will see a different set of 12 questions. Okay. I mentioned before that if you're used to working with conjoint analysis, it can be a little bit grumpy. And one of the places where conjoint analysis can run into some problems is if we have too many prohibitions. If we start adding things like, well, brand A can't be ever shown with advertising claim B, or, this feature can't ever be offered as part of a low price product. Those kind of prohibitions can sometimes pretty quickly degrade the quality of a conjoint design. Turns out MaxDiff is much less sensitive to the presence of prohibitions. You can add a fairly large number of prohibitions into the design and still get really good data out. So That's kind of a nice thing. We have several options for estimating utilities. There are some, and I'll go through these one at a time. There's some simple count-based methods for estimating utilities. If you don't even want to use a computer program to calculate your utilities, you don't have to. But there's easy easy statistical models we can use as well, and we'll go through those in turn. So for those count-based methods, in the original work that the academics did creating MaxDiff, they suggested a simple subtraction. We just count up the number of times an item is selected as best and the number of items it's selected as worst, and we subtract the worsts from the bests. Oh, the second worst there should say best, sorry. Anyway, so there's a simple subtraction. Alternatively, later on, and there's a really good book about MaxDiff, or about best-worst scaling by Louvier, Flynn, and Marley. So I would encourage you to look at that book for everything the academics have to tell you about MaxDiff. I think it's really valuable. Another suggestion was that you could count the number of times an item was selected as best, divide it by the number of times it was selected as worst, and then take the natural log of that. That's another way of estimating estimating utilities. And in 2014, Lipovetsky and Conklin provided an even more another way of using ratios of counts to get what they call the analytical best-worst score. We talk about all three of these methods in the book, and we show that at the sample level, these three methods are all very highly correlated with one another, and also very highly correlated with the utilities we would get from statistical modeling. So, so they're really a viable option sometimes. If you wanted to go the statistical modeling route, which is typically what we do, because once we have the MaxDiff design in our software, it's actually trivially easy to run these analyses. So one of them is what's called an aggregate logit. So multinomial logit is a statistical model that identifies a set of utilities that best predicts some set of observed choices. So whether we're doing choice-based conjoint or menu-based choice or adaptive choice-based conjoint or MaxDiff, we're forcing people to make choices. And then then the statistical model analyzes those choices and creates utilities. If we run a single model for our entire sample of respondents, that's called an aggregate logit. And we could also run separate logit models for each of the many subgroups of respondents. 20, 30 years ago when we were doing this is how we had to work. If we wanted to look at males and females, we had to run two aggregate logit models, one for all the male respondents and one for the females, and then one for each of the 7 different regions of the world, or each of high, medium, and low volume customers. So I remember doing studies where I would run 30 or 40 of these, one for each subgroup of interest to the client. Of course, that gets a little bit repetitive if you want to get utilities for lots of subgroups, and I'll show you the solution for that in a minute. Before we get there, though, sometimes those pre-identified groups we have, high, medium, and low volume customers, males and females, people from the South versus people from the West, they don't align perfectly with differences in preferences. People might like item A, and it might be totally unrelated to what region of the country they live in, what their gender is, or how many years of education they have. And as a result, sometimes we want to say, well, gee, let's not just look at our demographic subgroups. Let's find subgroups of respondents who have similar sets of utilities. And because the variables that define that group membership of people who have different sets of utilities doesn't already reside in our data, they're hidden. They're called latent. And that's where the fancy word latent class comes from. It's just a fancy way of saying we're going to find these classes that aren't already existing in our, that we don't already have a variable for in our data set. So that's a latent class version of multinomial logit. It's neat because it simultaneously identifies for us different segments of respondents, tells us how big those segments are, and it gives us the utilities for each of those segments. So as such, latent class multinomial logit is a really great way of doing segmentation with MaxDiff data. And it even has some really nice goodness of fit steps statistics to help us determine how many segments our sample contains. if you think about it, an aggregate model is giving us sort of everybody's, an average set of utilities for everybody, and latent class is breaking it down by groups of people with different patterns of preferences. The extreme case of that is when we want respondent level utilities, where we want to say, hey, each respondent is a unique individual, and let's give each respondent their own set of utilities. For that, we use something called Hierarchical Bayesian, or HB, multinomial logit. And this is really handy to have if you want the ability to slice and dice your utilities into lots of different segments, right? So now we don't have to run a separate model for males and a separate model for females, and then separate models for each of the, the census regions of the country, or each of the countries in Europe, or for each education level. We just run the analysis once, we get respondent level utilities, and then we can summarize all those observed groups of people, those demographic groups or whatever, and we can analyze them we can use our crosstab software or Excel or whatever, and show the average utilities for each group. The other reason we might want to have these respondent level utilities is we might want to run some other analyses on our data. Maybe we want to run some simulations or do turf analysis, and those are going to require respondent level utilities. Another capability we have in the software is to run utilities on the fly in real time during the survey. So if we've shown each respondent each item 3 or 4 times, then we can get sort of a fast estimate of what the utilities are while the survey is still running. And that allows us to do some neat things, right? So it could allow us to focus some open-end questions. Hey, I noticed that you really like that 60-day spa membership as the perk you're most interested in receiving for joining, our subscription program. Can you tell me why you like that? What is it about that one that made you like it the best or the worst or whatever? We see a lot of this sort of application in our concept testing work, because sometimes we don't want to know just which concepts are the winners. We want to know why, and asking these open-end questions can give us that. Another application of this on-the-fly utility estimation that I use a lot is to make my anchoring questions more respondent-friendly, and we'll talk a little bit more about that later on. When the utilities first come out of the, when the computer generates the utilities, they generate them according to they generate them to fit in the multinomial logit model, and that scales them in a way that allows us to predict choices mathematically. And as a result, having those logit scaled utilities allows us to run simulations, which is kind of neat. But for some other needs, we might want to try some other we have some other scaling options. Most of us weren't born knowing how to look at a set of utilities and interpret them as fitting in the multinomial logit model. We don't do the exponentiation steps and so on in our head that allows those utilities to be useful in that way. So one of the ways we might want to rescale the utilities is to make them comparable. It turns out that with logit models, if some respondents answer their questionnaire more consistently and some respondents answer less consistently, they end up having slightly different scales. In other words, respondents who answer more consistently have larger utilities, larger positives and larger negatives, and people who answer less consistently have their utilities pulled closer to 0. They have smaller negatives and smaller positives. And this could happen because maybe some people are experts in the topic and others don't know as much, or maybe some people are just paying more attention, or some people are distracted while they're answering the survey. Some people just have more ability to concentrate on a survey than other people do. So for a lot of reasons, we might see these differences in consistency. And if we want to get rid of those differences in consistency and say, hey, we don't want to segment our respondents or analyze them based on how consistent they were. We really care about what they value. We can rescale the utilities so that each respondent has the same range. They all have the same magnitude, and that makes them comparable. If we want to run statistical analysis like t-tests on the utilities or something like that, this is a good first step to do. Or when we're reporting our results to management, I found that audiences often appreciate scaling that they can understand. So we can do a probability rescaling. And when we do this, our utilities sum to 100%, and they have a ratio level interpretation. That means that a score of 60 we can interpret as being 4 times as valuable as a score of 15, or 10 times as valuable as a score of 6. So giving respondents numbers that have a more easily intuitable meaning to them, I found to be really useful. So I typically do this probability rescaling when I'm going to show the utilities to an audience. Okay, so I mentioned that MaxDiff was a little bit friendlier than conjoint analysis, say, in a lot of ways. And here's another way. MaxDiff was originally devised to allow us to estimate respondent level utilities. So remember that subtraction I showed you earlier. You take the number of most choices minus the number of least choices, or bests minus the worsts, and you get a score. If you read the Louvier MaxDiff book, you'll see that they oftentimes do that analysis among individual respondents, not just across the entire sample, but for individual respondents. So this was a way. I mean, MaxDiff existed before Hierarchical Bayes did. So back in the day, this was one of the ways that we were able to get respondent level utilities, which was kind of neat. As a result, MaxDiff scales down nicely for small samples. So if you're doing a business-to-business study or a pharmaceutical study where you've got a small and expensive number of respondents, MaxDiff works really well for a small number of people. Of course, when we go to generalize our sample results to the population, we still have to think about generalizability and precision and power the same way we would for any other kind of research. MaxDiff isn't magic in that respect. The laws of sample size still apply, so we still end up with general rules of thumb, like to get a really generalizable sample, we'd like a minimum of 300 respondents, or maybe 200 per separately reportable subgroup. That's good advice. There's also some calculations that you can do to compute what your sample size is. Most of my clients who do that aren't practitioners, because they're more willing to live with rules of thumb and so on, and they don't want to take the time typically to do the somewhat complicated calculations for computing sample size. But for my clients who are researchers who are maybe getting their funding from grants, or they're academics who have to explain their design decisions to journal editors, those kind of audiences I find do those kind of calculations. So. Okay, MaxDiff utilities are relative. You've got a question like this. Here's 4 horrible things that could happen to a person. Which one do we like best? Which one do we like least? Truth is, we don't like any of them. But if we've only done a MaxDiff, we're going to end up with some positive scores and some negative scores and some things on the top and things on the bottom. And we're not going to realize necessarily that all these things are bad. And that's why we want to do anchoring sometimes. We have respondents. One of the ways we could do this is we could have respondents tell us which of the items on the list are acceptable or which aren't, or which are important or which aren't. This is called the direct approach to anchoring. There's also an indirect approach using a dual response question. So the direct approach, again, either before or after the MaxDiff exercise, just add a select question like, which of these are important and which aren't important for each item on the list. Or if we want to make this more respondent friendly, if we've asked each respondent, if we've asked respondents enough questions to do those MaxDiff utilities on the fly, we can know, for a list of 21 items, what the ranking is for each of the items. And then we can go and ask the respondent, just maybe every 5th item, is it important or not? And use just those 5 items to set the anchor, which is a really efficient way to do it. The dual response way, as the name suggests, asks a second question. After each MaxDiff question, we're going to also ask, thinking about these items, is it the case that none of these are acceptable to me, or all of them are acceptable to me, or some are acceptable and some aren't? So it increases the effort of doing the MaxDiff task. But all we have to do is have the respondent check a box, and we can infer then analytically where the anchor is. I mentioned that MaxDiff has been a hit, and that's led to it being used in more kinds of research, and also it's led to people pushing the limits. If we can do 20 items, how about 30? What about 50 or 100 or 200? I think the last time I looked, about, I don't know what, 15% of our studies had more than 100 items. So these things are getting bigger and bigger over time. Several ways were presented over the years at Sawtooth software conferences. And one of these methods, Sparse MaxDiff, turned out to be, I think, the one that was the best. We've got some good empirical evidence that it does a really good job. When we say sparse, we just mean we're going to ask each item fewer than 3 times per respondent. Before I said we typically like to ask each item 3 or 4 times. Now we're going to say we're going to back off of that. So if we had 60 items, maybe we could show 30 sets of 4 items each where we're showing each item twice. Or maybe if we had 100 items, we could show 20 sets, 5 items each, and show each item only once. Those are examples of sparse MaxDiff. And there's another MaxDiff method called Bandit MaxDiff. Sometimes we only care about identifying the winners. And if we only care about the winners and don't care about the losers, we can actually learn across respondents so that later respondents answer surveys that have been adapted based on what earlier respondents told us. As a result, we get great precision about the best items, less precision about the worst items. But this is a big enough topic that coming up later this year, I think late spring or early summer, we're going to do another one of these webinars just about Bandit MaxDiff. So stay tuned for that. We talked about doing subgroup analyses with our MaxDiff utilities. We talked about segmentation using latent class. We talked about tailoring subsequent questions with on-the-fly utilities. We can also do simulations as I mentioned. And we can do turf analysis. We can identify the reach that a bundle of items has. So if we're thinking, if we're the ice cream store and we want to come up with, we want to add 6 new flavors to our menu, which set of 6 flavors is going to give the most respondents at least one flavor that they like? That's the kind of question we can answer with turf analysis. And finally, our last topic before we turn it over for questions. So best worst case 2 scaling, or the profile case of MaxDiff, is sort of a hybrid between MaxDiff and conjoint analysis. It's gone by a lot of names over the years. It was originally called best worst conjoint. Unlike other forms of conjoint analysis, this profile case of MaxDiff allows us to do cross-attribute level comparisons. So one of the no-nos when we're doing conjoint analysis, if we've got brands and prices and so on in there, we can't compare the utility of a given price point to the utility of a given brand or of one of the levels of color or one of the lengths of warranty that we've studied. With this kind of MaxDiff, you actually can do that. Now let's see. So here's an example of what such a question looks like. Which of these features of a subscription TV service would most make you want to subscribe, and which one would least make you want to subscribe? And you can imagine that we've got a conjoint-like design here where we have an attributes and levels structure. So we've got one attribute that's, which premium channels are available, and another one about how many basic cable channels are available, and a third attribute about how many free pay-per-view events someone can get each year. A one-time setup cost attribute that might be, $99, $199, $250, and then a monthly cost attribute that might have 4 or 5 levels. And in any one of the questions, it's going to look sort of like a conjoint profile, right? Here we've got the level specified for each of 5 attributes, and all the respondent's going to do is tell us which one of these attribute levels most makes them want to subscribe and which one least makes them want to subscribe. And when we analyze that data, then we have a utility for each level of each attribute. And the neat thing is the utilities for all the attributes are on the same scale. They all have the same 0 point, so they're directly comparable. My clients typically aren't using this kind of conjoint analysis for that reason, that they can make cross-attribute level comparisons. They're typically using it when they're working with populations that they think might have a hard time with choice-based conjoint, where we're showing people, 3 or 4 profiles at a time and asking them which one is best, because this is a little bit less cognitively demanding. We're really showing people only one profile at a time and asking them the best and worst thing about it. So that's where I typically see this kind of experiment used. Also, the fact that we can get those on-the-fly utilities I've had clients use this kind of experiment in their focus group research, right? So they give during the focus group, they have the respondent do this task, then they can get a readout of what that respondent's utilities are during the survey, and then they can, I'm sorry, not so much focus groups, one-on-one interviews, qualitative research. So for these, then in their one-on-one interview, they can ask the respondent, well, hey, I see that you seem to like this, this level of the attribute much more than this other level. Why is that? And it looks like you might trade this one off to get that one. Why is that? And so, so it can be valuable for that. You can even combine best worst case 2 with choice-based conjoint, right? And the easiest way to do that would be to follow up each of the best worst questions with essentially a none alternative, a yes no. So in the first half of the question, we're asking people which one of these elements of the profile they like best and which one they like the least. And then we're saying, hey, given what you know about TV services and such, would you really subscribe to the one above or not? And here they're giving us a holistic choice about the whole profile above. And in this way, we're combining best worst conjoint with MaxDiff. We could do the same thing if we just added a purchase intent question there at the end. Okay, so this is my summary. I mentioned that conjoint analysis sometimes can seem like a grumpy old dog, because if you're not careful, it's going to bite you. You got to make sure to get enough questions in there, and you've got to be sure to have the right kind of design, and don't have too many prohibitions, and be careful with this and be careful with that. But MaxDiff so MaxDiff isn't like the guy on the left there, Carl. He's really like the guy on the right. He's a happy puppy. I mean, at the drop of a hat, the puppy will let you roll over and tickle its tummy, right? That's kind of what MaxDiff is like for me. It's easier to design, it's easier to analyze, and it's a lot harder to make mistakes. And so that makes it a friendly puppy. If you'd like more information, we have a book with a lovely nautical cover on it there. I think it's available on Amazon, or you can buy it from our website or whatever. And if you've got questions, you can ask them now. Alternatively, if you're shy or we don't get time for your question, you can certainly send me an email. My email address is keith@sawtoothsoftware.com. I imagine if the presentation gets over and you forget that, you can just send a question to Brandon, who I think sent you the invite to this meeting. So with that, I'm going to turn it back over to Aaron.
Okay. All right. So we have quite a few questions. We've answered some of them as the presentation has gone along. So I'm just going to start here at the top. Keith, the first question is, in a typical MaxDiff question, is it recommended or important to add taking into account only the given options type verbiage to the question?
That's a really good question, and that does seem like a good idea, because you don't want there to be carryover effects from one question to the next. If they saw a vacation activity on the previous question that they really liked, so it might be obvious, but it can't hurt to add that, hey, just compare just among these four, because they really have to pick one as the best and one as the worst. So again, it may be obvious, but it's certainly probably a good idea to add.
Yeah, and I don't think it's quite as important as it is in like a choice-based, where you're forcing them to make a decision. But yeah,
agreed.
I agree. Next question, Dan Vandenberg asks, can you compare MaxDiff results across different studies? If the utility values are all relative to each other, seems like you can't compare across studies.
Ooh, that's a really good question. We've had some interesting papers come up at the conference where people have said, what I'd like my MaxDiffs to be comparable one study to the next. So they include two or three concepts in there that they've tested. These were for concept testing applications. So they included two or three concepts that they had already brought to market, and that either succeeded or failed or whatever. And they included those in each MaxDiff they did. And in that way, they were able to compare across studies, because they had those 3 or 4 existing products included each one that they could use to anchor across. Now, that's really only going to work very well if the appeal of those constant concepts is also constant over time and across audiences, and that may not be the case. So it seems seems to me that's a little bit problematic, but I have seen people do it.
Okay. Yeah, you also have to be a little bit careful because this, depending on what scale of utilities you're talking about, that can change based on the number of items that you were asking about and the number of items you had in your experiment and stuff. So, yeah. Okay. Next question. Can you use MaxDiff successfully for, let's say, 16 product and service attributes to determine which attributes are really important to the respondents and are really the key drivers?
Absolutely. That's probably one of the main uses I see of MaxDiff is to use it for importance measurement. So you can get the relative importance of your item list. And in fact, I've got a paper that we published in the International Journal of Market Research, I don't know, 10 or 15 years ago, where we compared MaxDiff for importance measurement with several other methods. We like the method appeared. We compared it to Q sorts, to constant sum scaling, a couple different kinds of rating scales, and magnitude estimation. And we found that MaxDiff was the most discriminating of all of those, and overall the winner among those 6. So we find it to be a very excellent way to do, to find out which attributes are important to people. And the neat thing we found there was that although we replicated that finding I talked about earlier from 1973, where we showed that importance ratings had no predictive validity. In fact, they had, in our study and in those 1973 studies, we found that importance ratings had negative predictive validity. That wasn't the case for MaxDiff. MaxDiff improves the predictive validity, so that was pretty cool.
Excellent. Okay, next question is, we often have surveys that combine conjoint and MaxDiff. Often we have too many attributes to put them all into a single conjoint. So we take the less important supplemental attributes and present them in a MaxDiff exercise. Do you see any benefit in including 1 or 2 of the MaxDiff items in the conjoint as a way of providing context for the MaxDiff exercise?
That's a good question, and yes, I would recommend that. I would like to know, I would like to get a feel for how the scaling of those 2 things compares. So, if there are things that we left out of the conjoint that really float to the top of the MaxDiff and are a lot more valuable than those things that we put in both the conjoint and the MaxDiff, then we might want to at least take our conjoint results with a grain of salt and realize that we might have left out some important attributes. That seems like a good idea to me.
Excellent. Okay, what's the recommended sample size for a MaxDiff study? You talked about a little bit. Can you just briefly comment on sample size, and then also the inverse? If I have 1,000 respondents, what's the maximum number of items that you could include in a MaxDiff study?
Oh, okay. Okay, so the first one, I typically, my knee-jerk reaction when I hear MaxDiff is what it would be if someone was asking me about factor analysis or regression. I'd say something like, we'd like to have at least 300 respondents in total, or at least 200 per separately reportable subgroup, right? That's just kind of a default answer for multivariate statistics. But as I mentioned, MaxDiff it scales down really nicely. So when I'm working with small audiences, if I've got a study of CFOs of Fortune 500 companies, and I'm only going to end up with a sample size of 25, I can feel pretty comfortable that that with MaxDiff I can get good utilities for those 25 people. Now, generalizing that 25 to the population is more of a problem, the same problem it would be with any other sample of size 25, but at least I feel I can get good answers for those 25 people. Now, the other question, I've never really had it posed to me that way. If I had 1,000 respondents, how many items could I have? Because the truth is, even with a small number of respondents, if I'm willing to do a sparse MaxDiff, I can do a pretty large number of items. So, up to 100 or 120 items I could do, even with a smaller sample of, 20 or 30 respondents potentially. But if I had 1,000 respondents, I might, and I might start to think, well, gee, I'm really unlimited now. I could do 500 or 1,000 attributes because I could do that Bandit MaxDiff, and get the larger Bandit requires a larger sample size. But if you have that kind of sample size to work with, I think the sky's the limit.
Okay. Yeah. Recognizing, of course, that you're not going to be getting individual level utilities for each of those people.
Yeah, not with the Bandit MaxDiff. That's correct.
Yeah. Yeah. So you have to be a little bit careful about things like, okay, well, great, you got 1,000 respondents, but if you need to then segment them into 100 different markets.
Oh yeah. It's a friendly puppy, but you can't abuse the puppy.
Yeah. Okay. Next question. Blocks are usually used to divide a design into several smaller versions in order to not overwhelm individual respondents. Is it recommended to further increase the number of blocks in MaxDiff for more precision, for instance?
Yes, I typically go with a large number of blocks, depending on my sample size. You know, I don't usually produce a larger number of blocks than I have sample size, but somewhere between 30 and 100 or 300, blocks is typically what I choose. And I do like having more because especially if I got a lot of items, it allows me to have, across the various blocks, it allows me to control for context effects, like, each item being shown equally often with each other item, and triples of items being shown together, order effects, which items are in the very first question that I ask. If I only ask one version of the survey, it's always going to be the same set of items that are shown first, right? Unless I rotate my questions. But if I have a lot of blocks or a lot of versions, then that's just going to even itself out. So there's just a lot of potential biases you can get rid of by having multiple blocks.
Okay. All right. Next question. In many commercial applications, the respondent struggles with the worst aspect. Can we just ask the best?
Yes. In fact, the software has a setting when you're setting up the experiment. If you only want to focus on the best items and and not include the worst part of the question, you can do that, and you can estimate utilities that way. So yes.
Okay. All right. And how is the dual choice information incorporated into the modeling and analysis?
The dual choice. For the dual response.
Correct.
It's done. What we essentially do is add an anchor item to when we're setting up the data file. We've got a column essentially in there for each one of the items except the last one, because it's dummy coding essentially of the items. But we add an additional item to the list, and if we give them that yes no, if we give them that yes no question, is this one valuable or important or whatever or not, any ones that they say are valuable or important or whatever the yes response is, we add some additional choice sets to each respondent's data file, and we show each of the items that they said was important as winning over the new anchor item, and any that they said were not important to them or were less important or whatever the no response is on that question, we show those in a pairwide question with each item, and those we show those as losing to the anchor. So it'll be each of the items against the anchor, and if it's a yes, the item beats the anchor. If it's a no, the item loses to the anchor, and that allows us to put the anchor in as being the 0 point on the utility scale.
Okay, and what if they say some of them are good?
If they do, I'm sorry. The question was specifically about the dual response.
Oh, okay, yeah, that's right.
Yeah, I'm sorry. I answered it for the other one. The dual response is a modification of that. I'm trying to think of the details. Maybe you know the details, Aaron?
Yeah. So if you say that all of them are good, then we set up an additional task that says that the none is worse than all the items that are shown. If you say that none of them are good, then we set up a task that says that all of the items are below the anchor. And if you say that some of them are good and some of them are bad, then we set up a task that says that the best thing is preferred over the anchor, but the anchor is preferred over the worst thing.
Okay, so we're just all the information we can positively infer from that question, we code into the design then.
Correct. Yep.
Thank you.
Okay, next question. What tools are required to do simulation?
The simulation in MaxDiff works the same way as it does in choice-based conjoint. We typically use the logit choice rule. So if in the extreme, you could use a hand calculator. As long as it had an exponential function, you could do that. More often, we can set up simulations in Excel. But we also have an online reporting tool called the MaxDiff Analyzer. And the MaxDiff Analyzer, you load your utilities in there, and it'll do and if you also load some subgroup identifying variables, it'll do a subgroup analysis for you. So if you want to look at how the utilities are different by males or females, it'll do that for you, or by 6 different income levels, it'll do that for you. There's also a way to do simulations in there, so you can tell it, hey, what if these 5 items were competing? What shares do you think how often do you think each one would be selected as best among these 5? As well, that tool does turf analysis and some other cool stuff, but that's probably the easiest way to do it. But it's not that difficult to build yourself in Excel either.
Okay. All right, next question here. Is there any, let's see here. How do you interpret the percent certainty?
Well, that's a fun one, isn't it? Okay. When Dan McFadden invented the logit model in 1974, he came up with a goodness of fit statistic that he called rho, the Greek letter rho. And it's typically called McFadden's rho squared, everywhere but in our software, where it's called the percent certainty. So, and I think the reason we call it that is you could think of it as measuring how close to a perfect fit, in the range between a perfectly bad random fit and a perfect fit where we predicted everyone's answers perfectly for every question. How far in that range? How far along in that range is the model? So a 65% percent certainty would say that, well, we're 65% of the way from randomly guessing up to perfectly guessing. So I guess that's the most natural way to interpret it, is how far along on the scale of random to perfect prediction are you? Now, that's a good intuitive way.
Okay. All right, let's see. We've got time for a few more questions here. Is it okay to change the best and worst wording to anything else?
You can change it to anything else that's relevant for your study. So which of these items would least make you consider a new product concept? Which one would most make you consider it? Which of these advertising executions do you like the best? Which one do you like the least? Which one of these would you most prefer to have? Which one of these would you least prefer to have? If you use MaxDiff for attitudinal scaling, and there's some neat papers that have been written in the academic literature, and also that we've shown at our conferences, using MaxDiff for psychographic scaling, it could even be you could give people a list of attributes and ask them which one, or a list of statements, and say which one of these statements do you agree with the most, and which one do you agree with the least. So it's really a neat thing about MaxDiff is it really allows researchers to be creative and do some pretty cool things. And I've seen some pretty neat applications. So that's another area where the sky's almost the limit.
Okay. All right. And then kind of a related question is, can you ask it as worst best instead of best worst? And are there any drawbacks to doing it that way?
No, there are no drawbacks to doing it that way. In fact, I think our software has 6 or 8 different options about where to put them. You can put them both on the left side of the items, or both on the right side, or one on the left and one on the right. And you can swap it and have best on the left and worst on the right, or worst on the left and best on the right. And the truth is, I don't know that I'm not aware of any empirical research that says what the best way to display those questions is. So one of the ways we learn things, and then we get to talk about them at these webinars, is that people do that kind of cool methodological research and they come show it off at our conference. So right now, I don't know the answer to that question, but maybe the question exists and someone else could find it. That would be cool too.
Excellent. Okay. Let's see here. David Bakken asks, have you ever conducted a MaxDiff where you start with the entire list of items and then successively eliminate the best and the worst items?
Yeah. I have seen people do that kind of complete rank ordering or partial rank ordering for MaxDiff questions, where maybe each MaxDiff question has 5 items, and they ask it first and say, which of these 5 is best and which of these 5 is worst. And then those get peeled off and 3 remain. And they say, okay, of the 3 remaining, which is best and which is worst. So I've seen, yeah, and there are papers out there about how to analyze that kind of what's called exploded rank order data. So yes.
Okay. And then final question we're going to answer. On slide 24, you mentioned that MaxDiff gave you a way to get respondent level utilities even before HB. Can you explain?
Oh, why that was cool? Well,
Yeah.
okay. Well, back in the old days, when we weren't doing surveys online and we didn't have this wonderful HB tool that gave us respondent level data for our choice-based studies, if we were doing a conjoint study, we could either do an old-fashioned ratings-based conjoint, which even back in the 90s felt kind of old-fashioned and out of date, and we didn't like doing them, or we could do a choice-based conjoint. But if we went the choice-based route, which we felt better about in all other ways, we didn't have a way to do anything but the aggregate logit. We couldn't get respondent level utilities unless we went with that outdated ratings-based conjoint and had to feel bad about ourselves. So when that best worst conjoint came along in the early 90s, it's like, wow, I can do a conjoint and it's choice-based and it gives me respondent level data. So it was like a really fun present under the Christmas tree when that came out.
Excellent.
Now it's mooted because we've got HB and we can get respondent level data even from choice-based conjoints. So we now have an even better Christmas present.
Excellent. Well, thank you, Keith. Just a reminder, recordings and PDF copies of the presentation will be available on the webinar page 24 hours after the event. So if you go to the same page you signed up with, you'll be able to see the materials from the webinar. The next webinar will be March 26th, when we'll have Brian McEwen presenting on 10 things you might not know about Discover. You can find more information on our website at www.sawtoothsoftware.com. And then if you go to the training and webinars, you'll find information on the next webinars upcoming. Also know that we have several other opportunities for training coming up. We have a 3-day CBC workshop in April. Actually, we have 2 of those, one in Anaheim and one in Rotterdam. So if you're in Europe, feel free to sign up for the Rotterdam one. Anywhere else, yeah, sign up for whichever one works best for you. And we cover CBC and ACBC and also MaxDiff. So, all right, well, thank you very much for attending, and keep in touch with us, and we'll see you at the next webinar.